Today we're going to talk about limiting reactant, and the limiting reactant is the one that is entirely used up whenever a reaction proceeds, and when that reactant is used up, the reaction actually stops occurring, and that is why we need to know the limiting reactant so we can figure out how much is going to be produced of the products. So for example, a very common limiting reactant example is if we have 2 pieces of bread and 1 piece of cheese, and the product here is 1 grilled cheese, and then if you have 2 starting amounts of reactant, so let's say we have 16 pieces of bread, and again 2 are used per grilled cheese, we can make 8 grilled cheese sandwiches. But if we only have 6 pieces of cheese, we can really only make 6 grilled cheese sandwiches. So we have to use this information and we have to figure out which ones are limiting, and our limiting is the cheese in this case. Therefore, if we were to say with these materials, we could only make 6 grilled cheeses. So even though the bread can produce 8, the cheese can only produce 6. So therefore, we can only really look at the amount of starting pieces of cheese to determine our products. So we're going to go ahead and look at another example using wheels. So if we have 4 tires to be utilized to build a bus, and we need 1 steering wheel, and 1 bus is created from that. And let's say we have 87 tires and we have 25 steering wheels. So the first thing we want to do is go ahead and figure out how many buses can be created with these materials individually. So I'm going to go ahead and take 87 and divide it by 4 because we need 4 tires. So theoretically we could make 21 point, I'm actually going to use my pen here, 21.75 buses. But obviously we know we can't make 3/4 of a bus, so I'm going to go ahead and say 21 buses with that one. And then we can go ahead and make 25 buses with the amount of steering wheels we have. So therefore, even though we could make more if we had more tires, we do not have enough tires. So therefore, our limiting in this case are the tires. And it's not the 4 tires, we just say the actual reactant name, which is tires. The excess is then the other reactant that there is going to be extra of. In this case, it is the steering wheels. And then our theoretical yield would be how many could we theoretically create with the amount of limiting. So the theoretical yield is based off of the limiting, not the excess. So our theoretical is 21 buses. Okay, so let's go ahead and do this in actual chemistry numbers. So I like to go ahead and always give you steps so that you can always look back if you forget how to do this. So the first thing you want to do is you have to figure out that it is a limiting reactant problem, and you're going to have to identify these. I will not be telling you it's a limiting reactant problem. And the way to identify that is you have 2 starting reactant amounts. And so you have to identify the 2 starting and say to yourself, okay, one is going to be limiting, one is going to be excess. Okay, and then you have to do some math to deduce which one is which. So we're going to go ahead and identify how much of each reactant. We're then going to use stoichiometry to each of from the reactants to the product, which we'll look at here in a second. And then the most important part is the one that produces the actual least amount is considered our limiting reactant. And then from that, we can figure out our theoretical yield of the experiment. What is a theoretical yield? So anytime you do an experiment, you anticipate, let's say, getting 10 grams of a substance. But then the experiment occurs, you drop a little, you weigh something incorrectly, and therefore maybe you only get 6 grams. So your theoretical yield is in a perfect experiment, in perfect situation, how much could you get? And we use stoichiometry to calculate our theoretical yield. But the other yield, which is more common, is called the experimental yield, or occasionally you'll see it as the actual yield. And these ones are actually what is produced. So then we like to go ahead and do a calculation at the end of any experiment to say how close was I to what I thought I would get. So I'm going to show you that in these examples. So the formula for percent yield is provided here. You will be provided for this on any tests or quizzes. Now the percent yield is the actual or the experimental. Again, this is the student or you, your data. And the theoretical, we have to do a stoichiometry calculation to calculate. And then like any normal percent, you have to multiply by 100. All right, since this is a lot of writing in these ones, I have this written out for you and we can kind of talk through it. So what we're looking at here is urea, which is given to you as CH4N2O, and it is used as a nitrogen fertilizer. And the data provided in the problem says 10 grams of the NH3, which is ammonia, and 10 grams of our CO2. And so we have a balanced equation. You have to, as usual, have a balanced equation. So we have this provided for us right here below. Now, again, you have to first identify this as limiting reactant. It will not tell you it is limiting reactant. So therefore, I, like I've suggested prior, like to write the information underneath each reactant or product. It just kind of gives you a good frame of reference of what you have, what you're provided with, and what you're trying to find. So I went ahead and wrote 10 grams under this one and 10 grams under this one. Again, we know this is limiting because we have two starting amounts. They don't have to both be in grams. They could be in moles. They could even be gas pressures. We may look at it a later chapter. Any two starting amounts, because one is limiting, one is excess. We're never going to have the perfect amount of both. And then what we're trying to find here is this urea CH4N2O. Okay? So the first question is, what is the theoretical yield? Well, we can't do the theoretical yield exactly. Well, we can't do the theoretical yield calculation until we have figured out what is the limiting and what is the excess. So how do you do this? You are going to go ahead and start out by writing, doing two stoichiometry calculations. And if you need a reminder of how to do those, please refer to my stoichiometry video prior to this. But we go ahead and we start with our 10 grams of whichever one you choose to do first. I chose to do the ammonia. And then you're going to go ahead, as usual, grams to moles using molar mass. And then we're going to go ahead and do that mole ratio step. So you have to be in moles. And what you're going to do is we're going to go to the one that we're trying to find. In this case, we're trying to find the urea, but it truly doesn't matter which product you go to as long as you go to the same product for both calculations. Okay, so moles to moles. So we went ahead and did a mole ratio using our balanced coefficients. And then I finished off in grams. I like to go to grams because it's easier for me to compare. Some teachers allow you to stop in moles, and if you want to do that, that's perfectly fine with me, as long as you show your work. I want to remind you, you always need to have units and identifiers for every single step of stoichiometry. So then you can see here, I decided that by doing this calculation, 17.6 grams of this urea would be produced from my 10 grams of the NH3. Now, we're not done yet. That's just one of them. We have to now do this again. So you can see here, I started again with the CO2 and went to moles, did a mole ratio, again, going to that exact same thing. Okay, you have to compare apples to apples. Went ahead and went to grams, and this one produced 13.8 grams of the urea. So now this is when you can finally decide what is my limiting and what is my excess. And you have to have both of these final answers to decide that. So as you read before, the one that produces the lesser amount, which you guys can see here is the 13.8, that is your limiting reactant. Now your limiting reactant is not the product. It is the reactant that produces the lesser amount. So in this case, it's the CO2. And then I actually like to label the other one as the excess. It just helps me as I move along further in this problem. So again, the most important component of this we've just learned is the 10 grams of the CO2. That's what we'll run out first. That's what will determine how much we get. Now let's finish this up by doing our percent yield equation. So go ahead and make sure you understand that your data or the student data goes on the top, and that's that 9.5 grams. And then the amount that you have calculated, that's why it's so important to know your theoretical. So we're going to go ahead and take 9.5 divided by 13.8. We're going to multiply by 100, and I got 68.8%. Remember, there is no sig figs for percents, so 1 or 2 decimal places is perfectly fine with me. Please do not cut it to a whole number. You're just creating too much inaccuracy. So again, what does this even mean? This means that the student that produced this reaction got about 68 or 69% of what they intended to get. So there was a pretty big percent error there. And sometimes in chemistry we then discuss what kind of errors could have occurred. Just a quick tidbit, you should never get over 100 on here. If you are, then you have done some calculation incorrectly. So why don't you go ahead and utilize the previous example and try this next example on your own. So you can pause the video here. I again have all the work, so we'll discuss it here in a minute, but try the one on your own using the example we just did. Okay, so here's our last example of limiting reactant. I did run out of room, so I had to go ahead and put it on 2 lines, but let's identify how we knew this was limiting. We knew it was limiting because we had 2 starting amounts of the reactants, not a reactant and a product, 2 reactants, meaning we have to figure out which one is the limiting, which one is the excess. So I went ahead and did the stoichiometry. The question was asking about CO2, so I chose to take both of these to the CO2 portion of the product. And my 2 answers here were 58 and 16. That's a very big clear difference. So the lesser one is this 16, meaning my O2 is my limiting reactant. Okay, again, that is the most important thing to decide in these types of problems. So therefore my C3H8 or the propane is the excess. Now let's finish this up by calculating our percent yield. I'm gonna have to put this over here in the corner. So what we're gonna do is take the amount they gave us, 14.5, divided by the answer that the limiting reactant produces, 16.5. Go ahead and multiply by 100 here, and we will see how close we were to what we intended to get. And I got 87.9%. Okay, so our percent of this experiment was 87.9, which is a pretty good one.